All right, rectangles. So remember on our family tree, the rectangle's dad is the parallelogram. So that means that rectangles are going to have all the same properties as our parallelogram. So I didn't list them all out here again, but all 5 of these apply to our rectangles as well. All right. In addition to those 5, we've got two more that apply to the rectangle and not the parallelogram. All 4 angles are right angles. So now these are all going to be right angles, meaning they are all 90 degrees. And then all of our diagonals are going to be congruent. So that means that this line is going to be congruent to this line. So remember, they bisect each other already due to our parallelogram properties, but now this total length is going to be the same as this total length. Okay, let's look at a couple examples. So we've got this rectangle, and we know that DB, so this total, is 42, and AD, this side is 26, and we know that angle DAE, so this little angle right here is 52 degrees. Let's figure out all these other things. So AC is inside our other diagonal. Remember, they're congruent, so that's 42. We want to know what ED is, and that is just one side of our diagonal, and we know that they bisect, so we can take 42 divided by 2, so that's going to be 21. BC, remember from our parallelogram, opposite sides are congruent, so the opposite side is 26, so BC is 26. We want to know what AB is. Okay, this is the tricky one that we're going to throw at you sometimes. So look what this right here makes. Remember, we said that in our rectangle, this angle right here is 90 degrees. So if I pull that out, this is A, this is B, and this is D. That's a right triangle, right? And we know this is 26, and we know this is 42. So I can use my A squared plus B squared equals C squared to find AB. B, let's say it's our B. So if I do the math, then our B is going to equal 33. Okay, let's look at our angles. We need ADC. That's this angle. We know that's 90 degrees. ABD is ABD is this one right here. And if we do our angles, then this is going to be 38, because this is 38 here if we take 90 minus 52. And BCA, this one right here, will be 52. Because of our alternate interior angles. Again. All right, this final example down here, we've got AE equals y plus 17. BE, 5y minus 23. We want to find the total AC, and then we want to find this angle. So let's look at the line first. So this is y plus 17, and BE is 5y minus 23. So remember that our diagonals are congruent. So this side would be the same here, y plus 17, and this would be 5y minus 23. So these two full lines, y plus 17 plus y plus 17 equals 5y minus 23 plus 5y minus 23. Get y by itself, y equals 10. I want to find what AC is, so I'm going to plug it into this side. Excuse me, equals AC. So when I add all those up, AC is 54. All right, let's look at these angles. Remember, parallel lines cut by a transversal, they are inside the parallel lines, opposite sides of the transversal. So these equal each other. Solve for x, x equals 2. What do we want to find? We want to find BCE. BCE. So this thing right here, we need to plug 2 in right here. So 11, write it down here, minus 3. 11 times 2 minus 3. Minus 3 is 19 degrees. Remember, this total is 90. So 90 degrees minus 19. 71 degrees equals our angle BC. Let me know if you have questions on rectangles.